Daniel is a senior researcher at Hassell, based in New York, I believe, and
That's great.
was previously a director of research at WeWork and wrote some columns for Architect Magazine, among others. Looking forward to your talk.
Cool, thanks, Claire. I'll just share my screen. Cool, so you can see that, eh? Cool. So yeah, thanks everyone for joining me today. I'm actually really humbled to be included in the lineup here. I don't know, normally when I come to a conference like this, there'll be like a few speakers that I have circled, but this time I went through the program and there were, I don't know, just so many I wanted to see. So congrats to Matteo, Dimitri, and Claire, and everyone else in the Speckle team for pulling this off. And I guess just while we're in the sort of preamble here, yes, it's a little bit of sort of like an unusual time in my life right now. I actually got married a week ago, and I know that everyone talks about how stressful it is to plan a wedding. And I don't know, I was sort of like, it can't really be that bad. It's sort of like just putting together a fancy dinner party. But it turns out all these people weren't lying, and it is quite tricky. Which is all to say that my presentation today is based on an article that I'm writing about the future of CAD, what I've termed here CAD's boring future. And I actually started this article months ago, and I really expected that it would have been published prior to this conference, and you would have all had a chance to read it and we could kind of discuss it. You know, there were sort of other priorities in the last couple of months. So I expect the article will be out in the next few weeks, provided I don't have to plan any more weddings. But until then, this presentation is actually, it follows pretty closely to the structure of the article. So in a way, I'm sort of giving you a preview of what this material is, and I'm really interested in getting your feedback on it. I also know this session is scheduled to be an hour, but I suspect it'll actually be closer to 30 minutes, which will hopefully give you a chance to see the other speakers after me. So I guess to kick this off, you know, like from time to time I get asked to give presentations on the future of design technology, and I think like people are sort of expecting me to kick off these sessions with like a sort of a bingo slide of acronyms and word pairs like machine learning and Internet of Things and augmented reality and generative design and 3D printing and big data. Like, I think people are expecting me to talk about technology, and it's not that technology isn't important, but I think at a technology conference like this, we have a tendency to overemphasize the technological innovation and sort of overlook some of the more obvious changes in the industry. So in other words, we're sort of looking at the future of CAD through a lens of technology, which can be limiting because technology isn't really the only driver of change. When I look at the industry today, for me personally, I think some of the more interesting trends in CAD and the industry as a whole have nothing really to do with technology. They're sort of far more prosaic, but also far less talked about. So in this presentation, I'm going to examine 3 CAD trends that I think are worth watching. Yeah, I've got them up on screen here, and we'll go into them in more detail. But I guess really the caveat here is that obviously the industry is like this huge entity that's going in many different directions simultaneously. So there isn't necessarily one future that everyone is heading towards. And I think you see this when you walk into an architecture firm, right? It's not like everyone in a firm is using BIM. You'll likely see designers using everything from, I don't know, 2D software like AutoCAD to parametric modeling tools like Grasshopper, and even tools like Rivet if they're doing BIM. And so in this sort of jumble of software, each of them sort of has their own trajectory, their own individual future, which is shaped by a series of different drivers. So the trends that I'm going to focus on, or these 3 trends that I'm going to focus on, they're not an exhaustive list of everything that's impacting the CAD industry right now. sort of, in addition to skipping over these technological developments, I've also basically just set aside cultural drivers such as the lack of housing affordability at the moment or problems with sustainability, primarily because I think there are people that are in a much better position to kind of describe and explore these issues than myself. And instead, what I've focused on is really the way that the industry is organized and the way that CAD is applied. And sort of against, I don't know, like that list of technological innovations, these three trends, they're not what I'd say like particularly sexy trends. But nevertheless, I think these concepts represent a fairly major shift in how the industry is operating, and the sort of trends that seem to be flying largely under the radar at the moment. So the first is what I've termed here the fat middle over the long tail, and I'll explain that in a little bit. But I guess as a sort of preamble into this one, you know, when I moved to New York I moved here probably like 6 years ago, and I was really surprised to discover that most buildings in the city, this city that I thought was famous for its design and fashion and architecture, were actually pretty ordinary. And actually, I remember like the first night that I'd spent in New York when I moved here, I didn't really know anything about the city except for what I'd seen sort of on the movies, and just how dirty and just I know plain a lot of the stuff was around me. I just picked this apartment off Craigslist, and yeah, it was definitely not what I was expecting in any way. And I mean, don't get me wrong, there's some great buildings in New York, but sort of if you're walking down any random street in New York, you're probably not going to pass them. Most of the buildings are fairly repetitive. And buildings in New York follow a common formula the same way houses in the suburbs follow a formula, the same way shopping malls, airports, office buildings follow a formula. So if you Google what New York looks like, you'll probably see these images of, I don't know, like Empire State Building and the Brooklyn Bridge, the Statue of Liberty, the Flatiron Building, whatever. But in truth, the built environment consists of these really unexceptional buildings. And one way I've been thinking about this conceptually is that you could basically gather every building in the world and organize them on a spectrum from the most unoriginal on one side to the most unique on the other side. And I think what's interesting about this is that if you think about the spectrum, at one end, you'd have a lot of like unoriginal projects, so a ton of like McMansions and gas stations and apartment buildings and shopping malls. And then at the other end of this, you'd have all of these sort of one-off unique projects like the Guggenheim Bilbao or Sagrada Familia. So just a couple of these really few unique projects. And of course, the unique buildings are really the ones that garner the most attention. They sort of tend to occupy a really outsized place within the media. But the reality is that architecture sort of follows this long tail distribution where most architecture is like tons of this unoriginal buildings, and then there's just a few truly unique ones. So in the early 2000s, around the time that Chris Anderson popularized the term long tail in his book of the same name and an article actually of the same name prior to that, the frontier of CAD was really down that unique end of the spectrum. At that time, most CAD software couldn't handle regular orthogonal projects. Well, most CAD software could handle regular orthogonal projects. But if you were to throw in a slanted wall or a doubly curved surface, the programs would inevitably fail. And to get around these limitations, designers would need to get creative. So only really elite architects like Frank Gehry could pull off these technological feats, which they basically flaunted through ever more difficult designs. And in many ways, this was a really strange period of architecture, a period where the criteria for good design was generally the harder a building was to design, the harder it was to construct, the more unique it was, the better. And so during this time, many of the industry's best and brightest worked to push the boundaries of what was computationally possible, helping realize buildings that were right at the end of that long tail. They poured their efforts into parametric models and optimization techniques that didn't necessarily enable better buildings, just more difficult ones. So tools like Rhino and Grasshopper became popular, not because of how efficiently they did the regular stuff, like the vertical walls present in 99% of projects, but rather their ability to do the unique stuff. And CAD companies took note and followed suit, releasing updates to their software that really stretched the ability of software to reach further and further down that uniqueness spectrum. And designers weren't just pushing the boundaries of uniqueness for the kind of sport of it. Underlying all these efforts was really a feeling at that time that architecture was limited by its design tools. And by pushing against these constraints, there was this sort of implicit hope that it would expand the design vocabulary, that it would open up new avenues of expression. The first projects might be challenging, but presumably everything would become easier with time. And if you sort of take that to the logical extreme, you end up in a place like parametricism, which is sort of predicting that the long tail is going to flip, right? That advances in design technology would progress to such a degree that soon every building would be unique, every building would be irregular and curved and different. And of course, this didn't happen. Instead, we seem to basically reach a point of diminishing returns. So projects with doubly curved surfaces and parametrically generated facades, they sort of began to feel like this magic trick that was used one too many times. The outcome was no longer surprising. And without the novelty, there wasn't that much worth celebrating. The buildings weren't any more affordable, they weren't any more abundant, they weren't any more sustainable, they weren't necessarily more pleasant to inhabit. And as such, I think you're starting to see that the enthusiasm for the long tail is beginning to wane. And in its place, people appear to be shifting their focus to the middle of the uniqueness spectrum. I guess just as an example of this, you can consider the recent crop of site feasibility software that's cropped up. So you have TestFit, which is up on screen now, but of course like Archistar and Spacemaker and others. And these companies, they all do basically the same thing. They make software that allows you to select a site and quickly generate a massing model and a pro forma. And it sounds simple enough, but having software automatically generate a building is actually like pretty cutting edge stuff. And a decade ago, you would only find this level of computational prowess on really big, expensive projects by famous architects. But here it's being applied to ordinary apartment buildings, car parks, and hotels. And these are projects that are like right in the middle of the uniqueness spectrum. Each project is a little different, normally due to site constraints, but they never stray too far from a template of fairly conventional project topologies. And I don't know, that's fine. I saw a similar thing when I was working at WeWork a couple of years ago. Back then, WeWork had this incredibly sophisticated method for delivering projects. Technologically, it was far beyond anything I'd seen anywhere else in the industry. But when you walked into WeWork's co-working spaces, it just looked like a regular office with sort of nice chairs and fancy couches. So although there was this computational sophistication, it wasn't necessarily overly expressed in the design. And just to give you a sense of some of what was happening on the back end here, this is a project that was done by, or led by Carlo Bailey at WeWork and the research team. And here's basically making predictions about which offices would sell. So taking all of this like Rivet information that WeWork had, extracting all of that. Well, there was another team extracting all that data and turning it into a database. Then he took all of that data from the database, combined it with all the sales databases, and then used machine learning to make predictions about which offices were going to sell based on physical attributes of the office. So really sophisticated combination of like BIM data, operational data, machine learning. But when you walked into a WeWork office, there's nothing that was sort of screaming like, this is like the absolute pinnacle of what's possible in CAD right now. This is the product of these really advanced computational algorithms and laser scanning and this really polished pipeline of BIM data. You know, like this is what $1 billion in venture funding from the Saudi government buys you. It just looks like a normal kind of office. And so I find this shift to the middle interesting because you're seeing basically so much computational expertise at the moment being brought to bear on what are really just such ordinary projects. And I know that calling these projects ordinary sounds like a critique, particularly if you come from a generation where you were rewarded for these difficult and unusual projects. But I think there's sort of a dignity in the ordinary. Now, most of the built environment isn't landmark projects with big budgets. It's normal, inconspicuous projects that you don't really think twice about. And I think this is really where one of the opportunities lies, the sort of the fat middle of architecture. These projects are challenging because there's so many financial constraints on them. So you can't afford to get too wild in what you're designing. But then there's also this overlay of practical considerations. You can't duplicate past work and expect it to work on a new site because the sites are so constrained and because there's so many other like constraints on them. And in many ways, I think it's the perfect problem for computational design. And more, I think you're going to see CAD turn its attention to this segment of architecture, shying away from the extraordinary in favor of making ordinary buildings better. The second concept I want to explore here is the idea of verticals over horizontals. Okay, here we go. So in the lead up to getting married, I had to get a ring. And obviously, buying a ring is like a huge story, but I'll just tell you one sort of tiny unexpected detail. And that was that the jeweler used Rhino to design the ring. And I mean, this isn't part of the engagement story that I normally tell my family, but since you're all here to hear about the future of CAD, the jeweler using Rhino, I know, to me, it's a big deal. And it's a big deal because I'm a fan of Rhino, right? I used it for many years when I was working as part of the design team, completing Antonio Gaudi's Strada Familia. And when my fiance and now wife and I went to a jeweler and asked them to help us design an engagement ring, I really didn't think that they'd use Rhino. I expected that they'd have some, you know, like specialized ring designing software. I don't know, we walked in there, we talked to them, we explained what we wanted, and they sent back that screenshot that you see on the left there. And I opened it up and I knew straight away that it was Rhino, obviously. And I know, I was really surprised to discover that this tool that I'd been using to model a massive church would be the same tool that they'd used to model the fine details of a ring. I mean, they're both momentous objects, but they're just so different. And I'd say most CAD software addresses a horizontal market. That is to say, the software serves a range of industries rather than targeting a customer in a particular segment. So Rhino is kind of the perfect example. Their software isn't exclusively for jewelers, nor is it exclusively for architects. Instead, they make CAD software that works in virtually any market segment, from engagement rings to 19th century churches and beyond. And even Rivet, which focuses on, in some ways, like a vertical, right? Like architecture, they take a fairly expansive approach to that, developing software that can be used to design everything from a single family standalone house to a huge skyscraper. And when you think about it, it's pretty easy to see why CAD companies take this horizontal approach. If you've built a tool that can draw 4 walls and a roof, it makes sense to sell that functionality to everyone that can possibly want it, even if they come from seemingly disparate segments of the industry. But I think there's also downsides to this horizontal approach, particularly when it comes to specificity and data exchange. So I'll start by looking at specificity. And I'll say that the challenge with designing CAD software for a horizontal market is that it has to basically generalize across a range of use cases. So if you consider how different it is to design a house compared to a skyscraper, like a house might be designed by a sole practitioner that only needs to create kind of a basic set of plans for a builder that they know personally, And then a skyscraper requires this huge team of specialists who need to collaboratively keep track of everything from, fire suppression systems to facade elements. And these two things are totally different, yet we expect Rivet to accommodate both of them and then some. And because Rivet stretches across so many different project topologies, it struggles with the specifics of each of them. So for example, people have been using Rivet to design apartment buildings, and they've been complaining for over a decade that Rivet can't count the number of units in a building. So the screenshots from the Rivet forum back in, I think, 2011, people complaining about Rivet not being able to count apartment buildings. And sure, you can kind of mess around with room schedules and write a Dynamo script, or you could buy a plugin to export and display this data. But all of that, when you do it, feels like a really complicated workaround. Software that specializes in designing apartments, such as TestFit, perform these calculations out of the box. So why does Rivet make it so difficult? And many of us will blame Autodesk and say that they're not listening or that they're moving too slowly. And so we've had this letter from Autodesk recently, or to Autodesk recently, and this is a article that I wrote about it. But I'd like to posit sort of like an alternative explanation other than Autodesk is lazy. And I think that's really that Rivet is horizontally integrated. In most cases, it's better for Autodesk to add features that benefit their entire user base rather than adding features that serve only one vertical. So in the case of counting residential apartments, it's better for them to support a generic tool like Dynamo than create a specific tool like an apartment counter. And obviously it feels like a lot of extra work to have every residential architecture firm basically creating their own apartment counter, but this is sort of by design. It's the natural byproduct of this horizontal model. The second issue that I want to look at is the problem of data exchange. And I know one of the more sort of challenging and persistent problems in the AC industry has been the exchange of data from one party to the next, particularly from the designer to the contractor and from the contractor to the owner and occupier. And in each of these transitions, information is inevitably lost. And this is perhaps best illustrated by this diagram, which I actually think was first drawn by Phil Bernstein. I call it the Sawtooth Diagram, which basically shows over the life cycle of a project. You have different entities and control of different stages of the project. They build up knowledge, and then that knowledge is lost as it enters a new phase because that knowledge can't be handed over through the standards that we have. And people blame this information loss on any number of things. The industry's adversarial nature, which sometimes hinders cooperation, a lack of technological finesse from project leaders, which means sometimes they don't know what information they should be asking for, a mismatch of sort of proprietary data standards, which sometimes makes it hard to exchange data. But I'd like to add one other thing, and that's horizontal integration. And basically, in my view, like a major reason that design exchange is challenging is because each phase of the project has its own software. So designers have their own tool that serve their horizontal, contractors have software tailored to their needs, and owners have another set of software for managing their properties. And the challenge of data exchange is really the barrier that is set up as the data passes from one horizontal to the next. And I'd posit that many of our frustrations with CAD software are really frustrations with the horizontal market. And there's this inherent tension in CAD software between the need to be specialized and focus on one particular area, or sort of one vertical, and the need to generalize and spread across and apply to many different verticals. I think what's interesting is that you're starting to see the rise of really focused, vertically integrated apps. So one of the problems with vertically integrated apps is that architecture firms themselves aren't vertically integrated. So it's common to see that architecture firms are trying to do everything from houses to urban plans to graphic design to anything else that they can sell. But we're also seeing this trend in architecture where firms are increasingly under pressure to become, or to go from being generalists to becoming specialists. And this is covered a lot in this book, The Future of the Professions. And really in The Future of Professions, the Suskins, they explore many drivers of what's changed the industry, but there's three really that focus on this increasing verticalization of the architecture industry. And so the first is this idea that we're moving from bespoke services into more sort of routine services. And you can see this all throughout the design process, whether it's complex projects that are so complex they can't be delivered without a really sort of focused pipeline of moves to get that project out of the door, or projects that are so sort of commonplace that it makes sense to use routine and automation. Makes sense to sort of focus the way that those projects are done so that they can be done in a more efficient manner. The second sort of driver there is what they're calling the more for less challenge, which is that firms are under these really intense financial pressures that are only going to get worse over time, and that they need to find ways to gain efficiency. And probably the easiest way to gain that efficiency is to specialize in one vertical and take the investment that you would put into, say, automation or other sort of forms of process improvement and spread that out across a number of projects in that vertical rather than focusing on many different markets where you can't necessarily gain that same efficiency. And the third thing that they talk about is routinization and decomposition. And basically they're talking there about some work is being more automated and other parts of it are being decomposed into smaller sort of pieces that are becoming more and more specialized. And so sort of one example of what this might look like is Hayworth's Co-Designer. So for those of you that don't know, Hayworth is a furniture company, and they made this design software, or they contracted out to another party to make this design software for them. And they give away the software basically as a sort of sales tool for them. And you can see already just from the screenshot that out of the box, they're doing a bunch of calculations such as they're counting the number of workstations there, they're calculating the density of the workspace, they're even scoring the quality of the workspace. All these sort of calculations that are definitely possible in software like Rivet, but would take a lot to sort of set up. They're all there sort of out of the box, ready to go. This GIF is super fast, and I'm not sure if it'll show up for you, but you can basically, in their software, just drag rooms around. So it's sort of generative, sort of interactive, and you can move things about. And this is probably, for me, one of the more interesting parts of their software. And what you're seeing here is a stacking diagram. So in office design, really typical to have all the floors represented and trying to work out which departments fit into which floors. And typically, workplace strategists or architects will use something like Excel or Illustrator to create a diagram like this. So it's totally disconnected from the design process. You basically create the stacking diagram, look at it, use it, and then throw it away because the design exists in another piece of software. But here, because it's done in their software, which is sort of just focusing on this one vertical, when you make this change to the stacking diagram, so you change where particular departments are within the office, it automatically changes the floor plan. So you have this kind of vertical flow of data from these early stages of briefing through to the finalized layout, and it's going backwards and forwards in this software. It also has a bunch of sort of generative stuff around placing desks. Again, stuff that isn't impossible in any other software, but because it's sort of baked in, it's much easier for people to access. This interactive corridor tool, which sort of shows off some of their bidirectional generative design capabilities. Does things like evaluates floor plans based on metrics that are important for people laying out offices. And so basically what you have is this very specific application that's designed for an incredibly narrow vertical. Like, you can't use Hayworth Co-Designer to design a house. You can't use it to design a stadium. You can't use it to design a cultural institution. Like, all you can design in it, you can't even design the outside of like an office building. All you can design within it is the interior layout of where desks and furniture are within an existing office building. And because it focuses on this one vertical, you get a lot of things out of the box that just aren't on other software like or that would have been possible, but they're just really tricky to implement. It's just an interesting example of what the future might hold, particularly when you have, I don't know, like a furniture manufacturer making this incredibly sophisticated sort of interactive generative tool just for the purpose of sales. The final concept that I'll touch on just briefly here is the idea of made to measure of a mass production. And this is, to be fair, like probably the least thought out section of the presentation. So it'll be somewhat brief, but yeah, love to get your feedback on this as well. So I think in the industry, we really have this obsession with making architecture like we make cars and planes. And this goes back decades, but I just pulled out a couple of examples of recent startups that have been talking about their design process in relation to industrialization using cars and planes as a metaphor. So Factory OS saying that housing should be built more like cars. You have shop architects who always have been sort of obsessed with airplanes, spinning off their own sort of subgroup called Assembly OSM, and they use this similar justification that like buildings should be manufactured like we manufacture planes. You even have the person that started Can I Has a Cheeseburger, the famous meme website. He founded this company, Social Construct, which recently folded, but sort of getting in on the same language here to describe this company, that we should be constructing in the same way that we use an assembly line. And I'm really not totally sure why planes and cars are the metaphor that we go to as an industry to describe how we should be building things. There's many other things in the world that get constructed in many different ways. And I don't know, I think I don't want to like psychoanalyze the industry, but I think there is something to like, why is it that we go to planes and cars as this example of manufacturing? And I think the future of construction for architecture may not be planes and cars, but might be something like suits. And I guess just sort of hear me out on this one. So I don't have a nice diagram for this one yet. I'm still thinking of that. But I think what's interesting is that you can look at the history of suits, and they've gone through these different phases of sort of production. And so initially, like a couple of 100 years ago, every piece of clothing, every suit was bespoke. You'd have to go to a tailor or make it yourself, and everything would be particular to a given person. The same way that you go to an architect today, and every building that we create is basically a bespoke one-off sort of thing. And then starting with the Industrial Revolution, you ended up with off-the-rack suits and other forms of clothing. So you basically had machines or humans assisted by machines mass manufacturing clothing that was for basically an idealized body. And this worked well for loose-fitting clothes like t-shirts and for people that had that idealized body, but it didn't work well for other people and other types of clothing that needed to fit more closely. So this is the same sort of problem that you have in architecture, where the body or the site is always a little different, and it's hard to make a one-size-fits-all building or suit because of those sort of constraints. And in recent years, there's been this focus in clothing on sort of made to measure. And it's been an idea that's been around for a while. And it was always sort of thought of as, I guess, the worst of both worlds. So it's not bespoke in the sense that you can't fully customize it. And it's not off the rack in the sense that it's not fast and efficient. You can just walk in and take it and don't have to pay a lot of money for it. But with the rise of the internet, it's a concept that's really taken off, and you're seeing it a lot more. And basically the way it works is that a tailor has a pattern or a block that they're using, and that it's adjusted numerically based on measurements that they're taking. So it's not fully bespoke because you can't change that much, but it's not fully off the rack either because it's made to someone's particular measurements. And this idea isn't kind of fully fleshed out, but I think rather than talking about architecture as being this sort of binary of either completely unique or completely modular, I think we should be heading towards this middle ground of sort of made to measure architecture. And I had one example here that I think sort of encapsulates some of this, and it's by a company called Generate Technologies, which is based in Boston. They do lots of really cool, super sustainable housing, and they use technology to do it. So they themselves have this sort of underlying pattern that they're using. They have a system of connecting the structure, and they have a sort of a formula that they use for the way things come together. But the projects they work on, like, they're not one size fits all. The site in this particular project, very constrained, very unusual, kind of weird diagonals on this site. And they have a way of basically adjusting what they're doing to fit that site. So it's neither totally bespoke in that what they're doing has this like underlying construction logic. It's not completely modular in that it's being adjusted to fit onto that site. And you know, like the projects they produce are really nice, sensible, good, sort of the fat middle of architecture using these computational techniques. So I guess if I was to summarize this presentation, like there are three sort of things that I think we're going to increasingly see in CAD and design in the coming years. One is this shift from focusing on really unique one-off, or using computational design to create these really unique one-off buildings, to using computational design to make the fat middle of architecture better and faster and higher quality. The second is this focus on software going from serving horizontal markets where it doesn't necessarily do particularly well in either data exchange or sort of focus on given features, to these verticals where there may be like particular tools that are tailored to really narrow verticals in the industry, and firms that sort of go alongside those that focus instead of wide and generalize on these very narrow parts of the industry. And finally, there's kind of shift from thinking about architecture as being either completely bespoke or completely modular to architecture that's enabled by computational design to be more made to measure. So having these like underlying facets of it that are thought out and worked out ahead of time, but adjusted to fit onto every body or every site that exists. So those are the three. Yeah, and that'll be the end of the presentation. Yeah, thank you all for coming. I'm not sure if there's questions and stuff in this forum, but you can always email me if you've got questions, or hit me up on Twitter or LinkedIn or whatever. Thank you.